Embark on an epic journey with 170 unbelievable scientific breakthroughs you've never heard of. Imagine a world where we clone super cows to revolutionize agriculture, use lasers to control the weather, and discover planets so Earth-like they challenge our uniqueness in the cosmos. From the depths of our brains where non-invasive implants unlock the mysteries of thought, to the edge of space, where we beam solar energy directly to Earth, these breakthroughs are not just changing the world, they're redefining our place in the universe. Witness the incredible as we unveil new dimensions of existence, from quantum entanglement visualized for the first time to AI predicting the unforeseeable impacts of global warming. This is not just science, it's the future unfolding before your very eyes. Are you ready to see what's beyond the horizon? The adventure begins now, and you won't believe what's in store. Discovery of the slim layer in the brain. In a groundbreaking discovery, scientists have identified a new layer within the human brain, named the slim, subarachnoid, lymphatic-like membrane. This delicate membrane is found nestled within the meninges, the protective layers surrounding the brain and spinal cord. The slim layer is intriguing for its dual role. It acts as a protective barrier against pathogens while hosting immune cells that diligently monitor and protect the brain from infections and inflammation. This discovery doesn't just add a new chapter to neuroanatomy textbooks. It opens up new avenues for understanding and treating a range of neurological conditions, potentially revolutionizing our approach to brain health and disease. Archaeological discovery of proto-writing. Archaeologists have made a monumental discovery in ancient caves, notational signs dating back 37,000 years, believed to be the earliest known form of proto-writing. These markings, found beside drawings of animal species, are thought to convey calendaric information related to the animal's behavior. This discovery is profound, pushing back the timeline of written communication and offering a rare glimpse into the cognitive abilities of early humans. It's a testament to our ancestors' ability to abstractly represent and communicate complex information, marking the dawn of a revolutionary form of human expression and interaction. Stentrode, a non-invasive brain implant. Medical technology has taken a significant leap forward with the introduction of Stentrode, a groundbreaking brain implant that can be inserted without the need for open brain surgery. This device is designed to record brain activity and translate it into actionable commands, enabling users to operate computers or other devices directly with their thoughts. The Stentrode represents a remarkable fusion of neuroscience and technology, offering new hope and possibilities for individuals with mobility or communication impairments. It's a vivid example of how advanced technology can bridge the gap between the human brain and the external world, creating new pathways for interaction and independence. Discovery of a second Earth-like planet in TOI 700 system. The cosmos continues to surprise and intrigue us, as evidenced by the discovery of a second potentially Earth-like planet in the TOI 700 system. This finding, made possible by NASA's Transiting Exoplanet Survey Satellite, TSSA, adds another candidate to the list of potentially habitable worlds beyond our solar system. The discovery of this planet, with conditions that may support life as we know it, fuels our curiosity and drives forward the quest to understand our place in the universe. It's a reminder of the vastness and mystery of space, beckoning us to keep exploring and unraveling the secrets of distant worlds. Impact of viral exposures on neurodegenerative diseases. In a significant medical breakthrough, researchers have found that exposure to certain viruses can substantially increase the risk of developing neurodegenerative diseases. This study sheds light on the complex interactions between viral infections and long-term neurological health, suggesting that our immune responses to these viruses might have lasting consequences on brain function. Understanding the link between viral exposures and neurodegenerative diseases could open new pathways for prevention, diagnosis, and treatment, offering hope to millions affected by conditions like Alzheimer's disease and altering the way we perceive and manage neurological health. Autonomous operation of modified F-16 fighter jets. The field of defense technology has witnessed a remarkable advancement with the successful autonomous operation of modified F-16 fighter jets. These jets, equipped with sophisticated AI systems, represent a new frontier in military capability, blending human strategic insight with the precision and speed of machine intelligence. The development of autonomous fighter jets marks a significant shift in the landscape of aerial combat and defense strategies, opening up new possibilities for remote and precise operations. As we navigate the ethical and strategic implications of this technology, it's clear that the future of military operations will be shaped by the integration of advanced AI, redefining the boundaries of human-machine collaboration in defense and beyond. Visual flicker paradigm and faster learning. Researchers have tapped into the brain's own rhythms to accelerate learning in a groundbreaking way. The study revolves around a visual flicker paradigm, a method that synchronizes visual stimuli with an individual's peak, alpha frequency, a brainwave rhythm associated with relaxed wakefulness. This synchronization led to a significant enhancement in visual learning speed and retention. The technique holds immense potential, suggesting that aligning educational methods with our brain's natural rhythms could unlock faster and more effective learning processes. It's a step towards personalized education techniques that could cater to individual learning styles and, potentially, aid those with learning disabilities. Cloning of super cows for increased milk productivity. In a significant leap for biotechnology, Chinese scientists have successfully cloned super cows with a remarkable increase in milk productivity. This breakthrough was achieved by identifying and replicating genes associated with high milk yield in cows, creating clones that inherit these desirable traits. While this advancement promises to meet the rising global demand for dairy efficiently, it also opens a Pandora's box of ethical considerations. Issues like genetic diversity, animal welfare, and the environmental impact of large-scale cloning practices are now at the forefront of discussions in the agricultural and ethical domains. AI's role in detecting early signs of Alzheimer's. The battle against Alzheimer's disease has seen a promising development with the advent of AI-driven diagnostic tools. Researchers have developed an AI algorithm that analyzes magnetic resonance images of the brain to estimate brain age and detect early signs of Alzheimer's, a condition traditionally challenging to diagnose in its initial stages. This AI tool identifies subtle patterns and changes in brain structure that may indicate the onset of the disease, offering a potential for early intervention strategies. It's a significant stride towards personalized medicine, where treatments can be tailored based on early accurate diagnosis, potentially altering the course of this devastating disease. Laser redirecting lightning. In a remarkable display of scientific innovation, researchers have demonstrated the ability to redirect lightning using lasers. This technology harnesses the power of high-intensity laser beams to create a path of ionized air particles, guiding the lightning safely to the ground. The potential applications are vast, from protecting critical infrastructure and buildings from lightning strikes to mitigating wildfire risks in drought-prone areas. It's a fusion of atmospheric science and laser technology, turning what was once science fiction into a practical solution to one of nature's most formidable forces. Reversing the aging process. In a groundbreaking study led by David Sinclair, researchers made a significant breakthrough in understanding aging by focusing on DNA breaks and their role in epigenetic changes. Utilizing Yamanaka factors, they demonstrated the potential to reverse aging in mammals. These factors, known for turning adult cells back to a stem cell-like state, were used to repair DNA damage and reverse the age-related epigenetic changes, effectively turning back the biological clock. The study showed promising results in mice, indicating a future where aging could potentially be controlled, dramatically impacting human health and longevity. Quaoar's ring system. Astronomers were taken aback when they discovered a ring system around Quaoar, a dwarf planet situated in the Kuiper Belt, far beyond Pluto. This discovery, made using the Cheops Space Telescope, challenges our current understanding of ring formation and sustainability, particularly around smaller celestial bodies. Rings are typically associated with gas giants like Saturn. Finding a ring system around a minor planet like Quaoar suggests that our solar system is more diverse and dynamic than previously thought. It raises questions about the formation mechanisms of rings and how they endure in different environments. Discovery of additional moons of Jupiter. The discovery of 12 new moons orbiting Jupiter brings the giant planet's total count of known moons to 92. This finding was made possible by advancements in telescopic technology and observational techniques. Each newly discovered moon provides a unique window into the early solar system's conditions and processes. Understanding their orbits, compositions, and interactions with Jupiter's complex system of rings and other moons helps astronomers piece together the cosmic puzzle of our solar system's formation and evolution. C 2022 E3 ZTF, Green Comet. C 2022 E3 ZTF, a comet originating from the distant Oort cloud, graced Earth's skies with its vivid green hue. This rare celestial event allowed astronomers and enthusiasts alike to witness a relic from the early solar system. The comet's green color, caused by the glowing of diatomic carbon when exposed to sunlight, provides insights into the comet's composition and the physical processes occurring as it approaches the sun. Observations of such comets contribute to our understanding of the solar system's outer reaches and the primordial materials from which it formed. First direct qubit transfer between quantum chips. In a groundbreaking experiment, researchers achieved the first direct transfer of qubits with an astonishing accuracy rate of 99.9999993% and a connection speed of 2424s. This was done between two quantum computer microchips, marking a significant stride toward scalable quantum computing. This achievement paves the way for building more complex and powerful quantum computers by enabling the connection of multiple quantum chips. It's a monumental step in harnessing the potential of quantum computing, which promises to revolutionize fields like cryptography, materials science, and complex problem-solving. AI predictions of global warming. Climate scientists used artificial intelligence to make a sobering prediction. Global warming is likely to exceed 1.5 degree Celsius within the next decade, with a significant chance of surpassing 2 degree Celsius by mid-century. This prediction underscores the urgent need for global climate action. The AI's ability to analyze vast and complex climate data sets offers a powerful tool for predicting and understanding climate change. These insights are crucial for policymakers, scientists, and communities as they strategize to mitigate the impacts of global warming and adapt to a changing climate. Safety by design in biosafety and biosecurity. In response to the potential risks of engineered pathogens, researchers are emphasizing safety by design approaches in biotechnology. These approaches include DNA sequence screening and biocontainment systems, aiming to prevent accidental or intentional releases of harmful pathogens. As biotechnology advances rapidly, integrating robust safety measures is crucial for preventing potential biosafety and biosecurity breaches. This proactive approach ensures that biotechnological innovations such as gene editing and synthetic biology benefit humanity while minimizing risks. Results of Calorie Longevity Trial. The Calorie Comprehensive Assessment of Long-Term Effects of Reducing Intake of Energy trial examined the effects of caloric restriction on aging. The results indicated that a 2-year period of non-intermittent caloric restriction could modestly slow the aging process. This study adds to the growing body of research suggesting that dietary interventions can impact the biological mechanisms of aging. Understanding these mechanisms may lead to new strategies for promoting health and longevity. Black holes as the origin of dark energy. A new hypothesis suggests that black holes may be the astrophysical origin of dark energy, the mysterious force driving the universe's accelerating expansion. This idea posits that the growth of black holes is intrinsically linked to the expansion of the universe, contributing to the observed effects of dark energy. If proven, this hypothesis could solve one of the most significant mysteries in cosmology: the nature of dark energy. It would reshape our understanding. Pre-installed apps and mass surveillance in China. A study revealed the role of pre-installed apps on Android smartphones in China in facilitating mass surveillance. This investigation highlights the intricate relationship between technology, privacy, and governance in the digital age. Understanding the mechanisms of digital surveillance is crucial for safeguarding privacy rights and fostering informed discussions about technology's role in society and governance. 3D printing like additive, 3D assembly, using holographic sound fields. Innovators have demonstrated a new method akin to 3D printing, but using holographic sound fields to assemble matter. This technique opens doors to rapid biofabrication and tissue engineering, offering a significant advantage over similar methods that use light. The ability to assemble complex structures using sound waves represents a leap forward in manufacturing and medical technology, potentially revolutionizing how we create intricate structures and biological tissues. Public health knowledge advancements. Various studies have strengthened our understanding of public health. For example, research shows the substantial health benefits of school meal programs, the link between ultra-processed foods and cancer mortality, and the positive impact of physical activity on mental health. These findings underscore the importance of holistic health policies and practices, emphasizing the interconnectedness of dietary habits, physical activity, and overall well-being. Record low Antarctic sea ice extent. The National Snow and Ice Data Center in the U.S. reported a new record low for Antarctic sea ice extent, surpassing the previous record set just a year earlier. This alarming trend highlights the pressing issue of climate change and its impact on polar regions. Monitoring sea ice extent is crucial for understanding global climate dynamics. The diminishing ice cover in Antarctica serves as a stark indicator of the rapid environmental changes occurring on our planet, urging immediate climate action. Integration of AI in military applications. The U.S. government published the Political Declaration on Responsible Military Use of Artificial Intelligence and Autonomy, proposing international norms and an arms control framework for AI in the military, including lethal autonomous weapon systems. The emergence of AI in military applications presents profound ethical, strategic, and security implications. Establishing a framework for responsible use is essential for maintaining international peace and stability, while harnessing the potential of AI technologies. Antimicrobial resistance in livestock antibiotics use. Antimicrobial resistant, AMR superbugs could cause up to 10 million deaths annually by 2050, a UN report warns. Factors like climate change and certain economic activities are exacerbating this threat. The report emphasizes a One Health approach, integrating human, animal, and environmental health strategies to combat AMR. A related study reveals a global decline in antibiotics use in livestock in Europe and China, thanks to new policies. However, the usage has increased worldwide. This rise in antibiotics, particularly in livestock, is a significant contributor to AMR, affecting not only animal health but also the environment and, subsequently, human health. Additionally, the emergence of super pigs, invasive hybrids of domestic pigs and wild boars, underscores the complex interplay between animal breeding practices, environmental management, and public health. Magnetic medical microbot, Raman. Researchers have made a significant breakthrough in medical technology by introducing the Raman, a magnetic medical microbot designed for cleaning clogged arteries. This innovative device could potentially replace more invasive endovascular surgeries. Operated magnetically, the microbot navigates through arteries, effectively targeting and eliminating blockages, akin to a pseudo-blood clot. This technology represents a leap forward in medical procedures, offering a less invasive, more precise, and potentially safer alternative to traditional surgical methods. Sexual loneliness and social dynamics. A profound study delves into the increasing issue of sexual loneliness, particularly among men, highlighting it as a significant yet overlooked public health concern. The research draws parallels between the distribution of wealth in highly unequal societies and the distribution of lifetime sex partners, noting a concentration of sexual activity among a small percentage of men. This imbalance, exacerbated by the dynamics of online dating platforms, raises complex questions about gender equality, social interaction, and mental health. The study suggests that addressing this form of loneliness is crucial for overall societal well-being. Organoid intelligence, OI. In a groundbreaking convergence of biology and artificial intelligence, scientists have introduced organoid intelligence, OI, a new field utilizing human brain organoids as a novel type of AI. This revolutionary approach involves cultivating networks of brain tissue organoids that can potentially perform complex computing tasks, surpassing the capabilities of silicon-based systems. Organoid intelligence holds promise not only for advanced computing, but also for understanding brain development, human learning, memory, intelligence, and exploring new treatments for brain diseases. Ethical considerations are paramount as this field seeks to harness the potential of human brain organoids responsibly. Advances in cancer and Alzheimer's disease screening. Recent advancements in medical screening technology signify a leap forward in the early detection and monitoring of diseases like cancer and Alzheimer's. One such innovation is a high-throughput static droplet microfluidic device, an inexpensive yet efficient tool that isolates and analyzes circulating tumor cells in the blood. This device offers potential for early cancer detection, making it a valuable tool in the fight against this disease. Furthermore, developments in retinal eye screening and monitoring biomarkers present a non-invasive approach to early Alzheimer's detection. Additionally, the discovery of autoantibody biomarkers in the blood offers a cost-effective method for Alzheimer's diagnosis, highlighting the strides made in medical technology for early and accurate disease detection. Launch of GPT-4.
In March 2023, the AI world saw a significant leap forward with the launch of GPT-4, the fourth generation of the generative pre-trained transformer developed by OpenAI. This iteration builds on its predecessor's capabilities, offering even more refined text generation that mimics human-like text with remarkable accuracy. GPT-4 has been trained on a vast dataset, encompassing a broad spectrum of human knowledge, which enables it to generate text that is not only coherent but contextually relevant across numerous subjects. Its applications span from writing assistance, coding, and content creation, to more sophisticated uses like simulating conversations, generating creative fiction, and even aiding in research by summarizing scientific papers.
Active volcanism on Venus. Evidence of active volcanism on Venus presents a groundbreaking discovery in planetary science, challenging previous perceptions of Venus as a geologically dormant world. Using reanalyzed images from past missions like NASA's Magellan spacecraft, scientists identified changes on the planet's surface consistent with recent volcanic activity. This finding suggests that Venus is not only geologically active but also offers insights into planetary evolution and dynamics, potentially reshaping our understanding of volcanic processes on rocky planets. High-risk pathogen labs. The global increase in high-risk pathogen labs designed to study dangerous viruses and bacteria under secure conditions has raised concerns about pandemic prevention and biosafety. While these labs play a crucial role in understanding pathogens and developing treatments, the expansion has sparked a debate about the risks of accidental or intentional release of deadly microbes. The situation calls for stringent international standards and oversight to manage these risks effectively while advancing scientific research. Carbon capture innovations. Innovations in carbon capture technology have made significant strides, with new methods showing promise in combating climate change by removing CO2 from the atmosphere more efficiently and economically. Techniques like transforming CO2 into bicarbonate of soda for safe storage in seawater, or using novel materials for direct air capture, could greatly enhance our ability to mitigate global warming. These technological advancements, coupled with policy support and investment, are critical for achieving large-scale carbon reduction goals. Discovery of ultra-cool dwarf binary pair. The ultra-cool dwarf binary pair, named LP41353AB, is a remarkable discovery in the field of astronomy. These are two of the oldest stars found to be orbiting each other in just 17 hours, providing invaluable insights into stellar evolution. Ultra-cool dwarfs are stars with relatively low temperatures and mass, and this particular pair's close proximity and rapid orbit challenge our understanding of stellar dynamics, offering clues about the formation and longevity of such celestial bodies. Deforestation and Greenwashing Investigation. An investigation into the greenwashing industry by the International Consortium of Investigative Journalists, ICIJ, revealed how environmental certifications are often granted to operations that continue to engage in deforestation and violate human rights. Greenwashing refers to the practice of making misleading claims about the environmental benefits of a product, service, or company practices. This investigation highlights the need for stricter environmental standards and more transparent certification processes to truly protect our planet. Havana Syndrome Report. The Havana Syndrome has been a mystery, with reports of diplomats and intelligence officers suffering from unexplained health issues. The U.S. Director of National Intelligence, DNI, reported that these incidents are very unlikely caused by foreign adversaries, suggesting other explanations for the symptoms reported. This conclusion may shift the focus towards understanding environmental or technological factors that could be causing these health issues. Impact of financial income on mental well-being. Research indicating that higher financial income can significantly increase mental well-being challenges the previously held belief that happiness plateaus beyond a certain income level. This study suggests that wealth can have a positive impact on mental health beyond just alleviating financial stress, potentially affecting overall life satisfaction and happiness. The findings could influence social and economic policies aimed at improving public mental health. Global Air Pollution Study. A comprehensive study on global air pollution revealed that almost no one in 2019 lived in areas with air quality better than the WHO's guidelines for PM 2.5, fine particulate matter that poses significant health risks. This alarming fact underscores the pervasive nature of air pollution and its potential impact on public health, highlighting the urgent need for global efforts to improve air quality. Ancient Europeans' DNA Study. The study of ancient Europeans' DNA is one of the largest of its kind, offering unprecedented insights into the ancestry and migrations of people during the last ice age. By examining genetic material from ancient hunter-gatherers, researchers have been able to trace shifts in populations and understand how humans adapted to changing environments over millennia. This research deepens our understanding of human history and evolution. Asteroidal Planetary Defense Test, DART results. The DART mission tested our ability to deflect a potential asteroid collision with Earth through a kinetic impactor technique. By crashing a spacecraft into an asteroid, scientists aimed to change its trajectory. The successful demonstration of this planetary defense strategy marks a significant advancement in our preparedness for potential asteroid threats, ensuring that we have the capabilities to protect our planet from celestial objects. Nitrogen-doped lutetium hydride as a room-temperature superconductor. Researchers have demonstrated nitrogen-doped lutetium hydride as a viable superconducting material at room temperature under high pressure. Superconductors are materials that can conduct electricity without resistance, potentially revolutionizing power transmission, magnetic levitation trains, and various electronic devices by significantly reducing energy loss. Development of a fuel cell implant, powered by blood glucose. A groundbreaking fuel cell implant that can generate energy from blood glucose has been developed. This device not only represents a significant advancement in medical implants, potentially powering devices like pacemakers or insulin pumps without the need for external batteries, but also opens new avenues in harnessing bioenergy for various applications. Unexplained rise of CFC emissions. In a surprising development, scientists have observed a concerning rise in the emissions of 5 types of chlorofluorocarbons, CFCs, chemicals previously banned by the 1989 Montreal Protocol due to their harmful effects on the ozone layer. Despite global efforts to curb these emissions, recent data indicates their climate impact in 2020 was comparably to Denmark's CO2 emissions in 2018. This resurgence poses a significant threat to climate change mitigation efforts and suggests a need for enhanced monitoring and regulatory measures to identify and address the sources of these unexpected emissions. Body temperature and lifespan. A groundbreaking study has revealed a direct link between body temperature and lifespan, affirming that a moderate decrease in body temperature can significantly extend life. This research builds on the understanding that lower body temperatures can slow down metabolic processes, potentially reducing the accumulation of age-related damage in cells. This insight opens new avenues for research into longevity and anti-aging interventions, suggesting that managing body temperature could be a key factor in promoting a longer, healthier life. Neuronal glucose metabolism. Recent scientific advances have shed light on how neurons, the fundamental units of the brain, obtain and utilize energy. A study has demonstrated that neurons metabolize glucose through glycolysis, a process previously not fully understood in the context of brain function. This finding is crucial because it links glucose metabolism directly to cognitive performance and brain health, suggesting that dietary glucose has a profound impact on mental capabilities and overall neurological well-being. Genomic surveillance of wheat blast fungus. In the realm of agriculture and food security, genomic surveillance has identified the global spread of a clonal lineage of the wheat blast fungus, a significant threat to wheat crops worldwide. This surveillance is pivotal for tracking the fungus's evolution and spread, highlighting the urgent need for global strategies to mitigate this potential pandemic threat to the food supply. With the fungus possibly becoming insensitive to fungicides, the study underscores the importance of genomic tools in safeguarding crops and ensuring food security. Discovery of new exoplanet HIP 9977b. Astronomers have made an exciting discovery, identifying a new exoplanet named HIP 9970b, situated 133 light-years away from Earth. This planet was directly imaged, offering scientists a unique glimpse into its characteristics and the environment surrounding it. Such discoveries are critical for expanding our understanding of the universe and the diverse array of planetary systems, potentially leading to insights into the conditions necessary for life beyond Earth. Jupiter Icy Moons Explorer, JUICE launch. The European Space Agency's ambitious mission, the Jupiter Icy Moons Explorer, JUICE, has been launched to investigate the potential for life in the Jovian system, particularly focusing on the icy moons Ganymede, Callisto, and Europa. Set to arrive in 2031, JUICE will study these moons' atmospheres, surfaces, and subsurface oceans, utilizing cutting-edge instruments and technology to probe their habitability and geological history. This mission represents a significant leap forward in our quest to understand the outer solar system and the potential for life on other worlds. Improving MRI brain scan resolution. In a remarkable technological breakthrough, researchers have developed a technique that significantly enhances the resolution of post-mortem MRI brain scans, achieving a level of detail 64 million times greater than previous methods. This advancement allows for the sharpest ever images of entire brains, facilitating unprecedented insights into the intricate structures and functionalities of the brain. Such high-resolution imaging is essential for advancing our understanding of neurological diseases and the complex workings of the brain, offering new pathways for medical research and diagnosis. Global surveillance of antimicrobial resistance. In April 2023, the importance of global genomic surveillance in combating antimicrobial resistance, AMR, was highlighted through a significant study. AMR poses a major health threat by making infections harder to treat. Genomic surveillance, which involves analyzing pathogens' genomes to identify resistance, is key to tracking and managing these threats globally. It helps detect emerging resistance and inform treatment strategies, emphasizing the need for international collaboration. This approach underscores a One Health perspective, recognizing the interconnectedness of human, animal, and environmental health in addressing AMR, and highlights the critical need for worldwide efforts to monitor and combat the spread of resistant pathogens. Semantic decoding through brain reading. Researchers have developed a groundbreaking brain reading technology that uses functional magnetic resonance imaging, fMRI, to interpret brain activity as a stream of text. By analyzing 16 hours of fMRI data per participant, this system leverages advanced machine learning algorithms to decode the semantic information, essentially, what a person is thinking about, in real time. This innovation could revolutionize communication for people with severe speech or mobility impairments and deepen our understanding of how thoughts are organized in the brain. Detectability of human civilization from afar. A recent study explored whether current human-generated radio emissions could be detected by advanced extraterrestrial civilizations. Researchers concluded that signals from mobile towers on Earth are too weak to be detected by even the most sophisticated telescopes planned for the near future, from any of Earth's closest star systems. This research is crucial for the search for extraterrestrial intelligence, SETI, providing insights into how and where we might expect to find signs of intelligent life in the cosmos. Brain activity at the end of life. In an intriguing study, EEG data from dying humans revealed a significant increase in gamma wave activity and brain connectivity in several patients, offering a glimpse into the neurological processes at death. This surge could relate to the phenomenon of near-death experiences reported by those who have come close to dying but were revived. Understanding these final moments of brain activity could help medical professionals improve end-of-life care and further our comprehension of consciousness. AI-boosted antibody response for COVID-19 vaccines. Scientists at Baidu have developed an AI algorithm that significantly enhances the antibody response of COVID-19 mRNA vaccines. By optimizing the vaccine's molecular design, the AI increased its efficacy by an astonishing 128 times in laboratory settings. This breakthrough demonstrates the potential of integrating artificial intelligence into vaccine development, potentially leading to more effective vaccines against a wide range of diseases faster than ever before. Single-molecule valve for nanoscale fluid control. A pioneering achievement in nanotechnology, the single-molecule valve represents a monumental step in our ability to manipulate fluids at the nanoscale. This valve can control the flow of individual molecules, opening new avenues in precision medicine and microfluidic devices. Such control could revolutionize drug delivery systems, allowing for targeted treatment at the cellular level and advance research in a variety of scientific fields where minute quantities of fluid must be precisely managed. Infrared view of asteroid belts around Fomalhaut. Using the James Webb Space Telescope, astronomers have captured the first-ever infrared image of asteroid belts around Fomalhaut, a star 25 light-years away from Earth. This observation revealed 3 distinct rings of debris, providing valuable insights into the composition and structure of extrasolar systems. Such discoveries are key to understanding planetary formation processes and the dynamics of celestial bodies outside our solar system. More complex model of human evolution. Advancements in genetic research have revealed a more complex narrative of human evolution. Contrary to the idea of a single origin, new findings suggest that modern humans evolved from multiple regions across Africa over various periods. This nuanced understanding challenges previous evolutionary models and highlights the diverse and interconnected paths that led to the emergence of Homo sapiens. This complexity enriches our knowledge of human ancestry and emphasizes the intricate tapestry of our evolution. Artificial intelligence in health risk prediction. In May 2023, a remarkable application of artificial intelligence, AI, in the medical field was demonstrated through its use in predicting the risk of pancreatic cancer up to 3 years before diagnosis. This breakthrough utilizes AI algorithms to analyze vast amounts of patient medical records, identifying patterns and risk factors that are not easily discernible by human practitioners. By leveraging machine learning techniques, these algorithms can predict the likelihood of developing pancreatic cancer, enabling early intervention and potentially saving lives. This represents a significant advancement in predictive medicine, offering a proactive approach to healthcare by harnessing the predictive power of AI to spot early signs of serious diseases. Human pangenome and genetic diversity. The concept of a pangenome encompasses the full genetic diversity found within a species. In May 2023, scientists presented a draft of the human pangenome, which includes 47 genomes from a diverse group of individuals. This effort expands our understanding beyond the reference genome compiled from a limited number of individuals to a more inclusive representation that captures the vast genetic diversity across different human populations. This has profound implications for personalized medicine. as treatments can be tailored to better match the genetic makeup of diverse populations, improving the effectiveness of medical interventions and reducing adverse reactions. Macroscopic multicellularity evolution. The evolution of multicellularity from single-celled ancestors is one of the major transitions in the history of life. In May 2023, researchers shared insights into this process through experimental evolution, demonstrating how multicellular organisms could emerge under laboratory conditions. By subjecting populations of single-celled organisms to selective pressures that favor cooperation and specialization, scientists can observe the emergence of multicellular life forms. These studies help us understand the underlying principles and evolutionary steps that led to the complex life forms we see today, shedding light on the origins of biodiversity and complex biological structures. Mental health and economic factors. A study reported in May 2023 highlighted the significant impact of economic factors on mental health and cognitive development. Researchers found correlations between low income, brain structure, and hippocampal volume, with stronger associations observed in U.S. states with higher costs of living. Conversely, the negative impacts were less pronounced in regions with stronger social safety nets for low-income individuals. This underscores the critical role of economic stability and social support systems in promoting mental health and cognitive development, suggesting that policies aimed at reducing economic disparities could have far-reaching benefits for societal well-being. Universal influenza vaccine trial. The National Institutes of Health initiated a Phase 1 trial for a groundbreaking mRNA-based universal influenza vaccine in May 2023. This vaccine aims to provide broad protection against a wide range of influenza viruses, contrasting with current flu vaccines that need to be updated annually to match circulating strains. The use of mRNA technology, similar to that employed in COVID-19 vaccines, allows for rapid development and adaptation to emerging flu strains. If successful, this could mark a significant advancement in our ability to prevent influenza outbreaks, reducing the global health burden of the flu. Neuromolecular mechanics of parasite-induced behavior changes. Research into the neuromolecular mechanics behind parasite-induced behavior changes in insects offers fascinating insights into how organisms interact with their environment. In May 2023, a study detailed how a fungal parasite affects insect behavior at the molecular level, manipulating the host to facilitate the parasite's life cycle. Understanding these interactions at a molecular level not only sheds light on the complex relationships between organisms but also opens potential avenues for developing treatments for neurological disorders in humans by applying knowledge gained from these natural phenomena. Global climate and environmental policies. A review of methane mitigation policies and a study on the human cost of global warming were among the key topics in May 2023, addressing urgent issues in climate change and environmental policy. The findings underscored the inadequacy of current efforts to cover and effectively mitigate methane emissions, a potent greenhouse gas, and highlighted the severe human and ecological impacts of projected global warming scenarios. These studies emphasize the need for more comprehensive and effective global policies to address climate change, aiming to reduce emissions, enhance sustainability, and mitigate the adverse impacts on populations around the world. Quantum computing developments. IBM's announcement of the development of a 100,000-qubit quantum computer by 2033 represents a monumental leap in computing technology. Quantum computers use qubits to perform complex calculations much more efficiently than traditional computers, offering transformative potential across various fields, including cryptography, drug discovery, and climate modeling. This development signifies a move towards harnessing the full potential of quantum computing, promising to solve problems that are currently intractable for classical computers and opening new frontiers in scientific research and technological innovation. Discovery of new moons of Saturn. In May 2023, the astronomical community was abuzz with the announcement of 62 newly discovered moons orbiting Saturn, elevating its total to 145 moons and surpassing Jupiter as the planet with the most moons in our solar system. This discovery was made possible through advancements in telescopic technology and image analysis, allowing astronomers to spot these distant objects despite their small size and faint visibility. The significance of this finding lies not just in the numbers but in what these moons can tell us about the history and dynamics of the Saturnian system. By studying their orbits, compositions, and interactions, scientists can glean insights into the processes of planetary formation and the evolutionary history of our solar system. This discovery underscores the importance of continuous observation and the ever-evolving nature of our understanding of space. Antibiotic design by artificial intelligence. The use of artificial intelligence (AI) in designing a new antibiotic marks a revolutionary approach in the battle against drug-resistant bacteria. By employing machine learning algorithms, researchers can sift through vast chemical libraries to identify compounds with potential antibacterial properties. The AI system evaluates these compounds based on their structural features and known biological activities, predicting their effectiveness against specific bacteria. In this instance, AI was instrumental in developing an antibiotic effective against Acinetobacter baumannii, a notorious pathogen resistant to many existing antibiotics. This breakthrough demonstrates AI's potential to accelerate the discovery of novel therapeutics, offering a promising avenue to address the growing challenge of antibiotic resistance. Evidence of a second Kuiper belt. The revelation of a potential second Kuiper belt beyond Neptune is a significant milestone in understanding our cosmic neighborhood. The Kuiper belt is a ring of icy bodies, including dwarf planets and comets, orbiting the Sun at the edge of our solar system. This discovery was facilitated by observations and analyses using telescopes and space probes, which suggested the existence of another belt-like structure of icy objects beyond the known Kuiper belt. The implications of a second belt are profound, suggesting that the outer solar system is more complex than previously believed. It could offer new insights into the formation of solar systems and the distribution of icy bodies in the outer reaches, potentially holding clues to the origins of water and life on Earth. High-efficiency organic solar cells. The achievement of a 19.3% efficiency rate in organic solar cells represents a significant advancement in renewable energy technologies. Organic solar cells, made from carbon-based materials, offer several advantages over traditional silicon-based cells, including flexibility, lighter weight, and the potential for lower production costs. However, their efficiency in converting sunlight into electricity has historically lagged behind silicon cells. The recent breakthrough in efficiency is attributed to innovations in material science, particularly in the design and arrangement of organic molecules within the cells, which optimize the absorption of sunlight and conversion into electrical energy. This progress enhances the viability of organic solar cells as a sustainable energy solution, promising to expand the use of solar power in a wider array of applications. Exploration mission to asteroids. The announcement by the United Arab Emirates Space Agency of the MBR Explorer mission to explore 7 asteroids and attempt a landing on 269 Justitia in 2034 highlights the expanding scope of international space exploration. This mission aims to study asteroids up close, providing unprecedented data on their composition, structure, and possibly their origins. Asteroids are considered time capsules that can offer insights into the early solar system, including the materials present during the formation of planets and the origins of organic compounds that may have led to life on Earth. The technical challenges of such a mission involve advanced spacecraft design, navigation, and landing technologies, demonstrating the growing capabilities of space agencies around the world in contributing to our collective knowledge of space. Solar energy beamed from space. In a groundbreaking achievement, the California Institute of Technology, Caltech, successfully demonstrated the transmission of solar energy from space to Earth. This was accomplished using the MAPLE instrument aboard the SSPD-1 spacecraft, which was launched into orbit in January 2023. The technology involves collecting solar power in space, where solar panels can receive more consistent and potent sunlight free from atmospheric and day-night cycle interruptions, and then converting this power into microwaves or laser energy that is beamed back to Earth. Upon reaching a receiver on the ground, this energy is converted back into electricity. This space-based solar power concept could potentially offer an unlimited source of clean energy, addressing some of the most significant challenges facing renewable energy technologies today, such as intermittency and land use. Reinterpretation of the expanding universe. Lucas Lombrizer, a physicist, proposed a controversial reinterpretation of the data that underpins the current understanding of the universe's expansion. Since the late 1920s, the prevailing cosmological model has been that the universe is expanding, a conclusion drawn from observations that galaxies are moving away from us in all directions. However, Lombrizer suggests that this observed expansion might be more illusory, a mirage, rather than a physical reality. If proven, this hypothesis could radically alter our understanding of cosmological principles, challenging the foundation of the Big Bang theory and necessitating a re-evaluation of the fundamental forces and properties of the universe. Homo naledi's complex behaviors. Discoveries regarding Homo naledi, an extinct hominin species unearthed in South Africa, have challenged previous notions about the cognitive abilities associated with small-brained hominins. Scientists reported evidence suggesting that Homo naledi engaged in behaviors previously thought to be exclusive to species with larger brains, such as burying their dead, creating art, and using fire. These behaviors, dating back as far as 500,000 years ago, indicate a level of social complexity and cognitive ability that broadens our understanding of human evolution, suggesting that the capacity for culture and complex social practices may not be solely dependent on brain size. Chef robot learns from videos. A chef robot, developed to learn culinary skills by observing cooking videos, represents a significant advancement in robotics and artificial intelligence, AI. This robot utilizes machine learning algorithms to analyze video content, extract cooking techniques, recipes, and processes, and then applies this knowledge to prepare dishes. This approach to robotic learning, mimicking the way humans learn by observation and imitation, showcases the potential for robots to perform complex tasks and adapt to a wide range of activities. Beyond the kitchen, this technology indicates a future where AI can learn from diverse forms of unstructured data to undertake tasks in various domains. Mycorrhizal fungi's role in carbon storage. A global estimate suggests that mycorrhizal fungi, through their soil mycelium networks, are responsible for storing approximately 36% of the annual CO2 emissions from fossil fuels. Mycorrhizal fungi form symbiotic relationships with the roots of most plant species, facilitating water and nutrient exchange for carbohydrates. These extensive underground networks also play a critical role in the carbon cycle by sequestering carbon dioxide from the atmosphere into the soil. This discovery highlights the fungi's vital role in mitigating climate change and underscores the importance of preserving biodiversity and ecosystem health as part of global carbon management strategies. Anticipation of complete Arctic sea ice disappearance. A study predicts the first complete disappearance of Arctic sea ice could occur during the 2030s, significantly earlier than previously forecasted. This projection is based on advanced climate models that account for rising global temperatures due to increased greenhouse gas emissions. The loss of Arctic sea ice would have profound implications for global climate, including accelerated warming due to the reduction of the albedo effect, whereby ice reflects sunlight back into space, rising sea levels, and dramatic impacts on Arctic ecosystems and indigenous communities. This finding serves as a stark reminder of the urgent need to address climate change and reduce global carbon emissions. Central nervous system viral diseases mechanism. A groundbreaking discovery has unveiled a new mechanism by which viral diseases affect the central nervous system, the fusion of brain cells. This process, observed in the context of COVID-19 and potentially applicable to a range of viral infections, involves the merging of infected cells with neighboring cells. This cell fusion can lead to abnormal cellular conglomerates that disrupt normal brain function. Understanding this mechanism opens new avenues for the development of treatments aimed at preventing or limiting the fusion process, potentially mitigating the neurological impact of viral infections. It underscores the complexity of the brain's response to viral attacks and highlights the need for targeted research to address the repercussions of viral diseases on the nervous system. El Niño's global impact. The onset of El Niño, confirmed by U.S. scientists, marks a significant climatic event expected to raise global temperatures in late 2023 and into 2024. El Niño is characterized by the periodic warming of ocean surface temperatures in the Pacific Ocean. This phenomenon has far-reaching effects on weather patterns globally, including increased precipitation in some regions and droughts in others. The confirmation of El Niño's arrival underlines the interconnectedness of global climate systems and the importance of preparing for its diverse impacts on agriculture, water supply, and natural ecosystems. Understanding El Niño's mechanisms and effects is crucial for predicting its consequences and implementing strategies to mitigate its impact on human societies and the natural world. Taurine's lifespan extension in animals. Research has revealed that taurine, a naturally occurring amino acid, can significantly extend the lifespan of various animal species by up to 12%. Taurine is involved in numerous biological processes, including bile salt formation, eye health, heart function, and the development and function of skeletal muscle, the central nervous system, and the cardiovascular system. This discovery points to the potential of taurine supplementation to promote health and longevity, not just in animals, but possibly in humans as well. The mechanisms by which taurine exerts these effects are thought to involve its antioxidant properties, regulation of calcium signaling, and support of mitochondrial function, all of which play roles in aging and longevity. Global Human Time Use Study. A novel time use study has provided a comprehensive overview of how humans across the globe allocate their time to various activities, establishing a global human day framework. This research sheds light on the distribution of time spent on work, leisure, chores, and other activities, offering insights into economic, societal, and technological impacts on daily life. Such a framework can help identify trends, inequalities, and potential areas for improvement in time management and policymaking. Understanding global time use patterns is essential for addressing challenges related to work-life balance, productivity, and well-being, and can inform strategies to enhance the quality of life worldwide. Synthetic human model embryos. The creation of synthetic human model embryos from stem cells, without the need for sperm or egg cells, represents a significant scientific milestone. This technology allows researchers to study the early stages of human development, disease processes, and the potential for regenerative medicine. However, it also poses ethical and legal challenges, as it blurs the lines between natural and artificial life forms. The development of synthetic embryos prompts a reevaluation of ethical guidelines and regulations to ensure responsible use in research and therapeutic applications, balancing scientific advancement with ethical considerations. Earth's formation timeline. Recent evidence suggests that Earth may have formed much more rapidly than previously believed, possibly within just 3 million years, rather than the long-standing estimate of 100 million years. This revised timeline is based on analyses of isotopic compositions and the accretion processes of planetary formation. A faster formation period implies that Earth's early environment and the conditions necessary for life's emergence may have stabilized sooner than thought. This revelation not only refines our understanding of planetary science, but also has implications for the study of other planetary systems and the search for life beyond Earth. Phosphates on Enceladus. The detection of phosphates on Enceladus, one of Saturn's moons, completes the discovery of essential chemical ingredients for life as we know it. Phosphates play a crucial role in biological processes, including the formation of DNA and RNA, and the energy transfer within cells. This finding adds to previous detections of water vapor, organic molecules, and other life-supporting chemicals in Enceladus's subsurface ocean, suggesting that this moon could potentially harbor conditions suitable for life. The presence of these basic ingredients underscores the moon's significance in the search for extraterrestrial life and highlights the need for future missions to explore its ocean and ice for signs of habitability. Quantum computing superiority.
Quantum computing represents a revolutionary approach to information processing, leveraging the principles of quantum mechanics to perform complex calculations far more efficiently than traditional computers. IBM scientists have made a significant breakthrough by demonstrating that a quantum computer can outperform a conventional supercomputer in solving specific physics problems. Unlike classical computers, which use bits, zeros, and ones to process information, quantum computers use quantum bits or qubits, which can exist in multiple states simultaneously, thanks to superposition and entanglement. This allows quantum computers to analyze vast data sets and solve problems in cryptography, material science, and other fields at unprecedented speeds, potentially transforming industries by making previously intractable problems solvable.
Discovery of senolytic chemicals through machine learning. Machine learning, a subset of artificial intelligence, AI, has been employed to identify chemicals with senolytic activity, capable of selectively eliminating senescent cells. Senescent cells are aged cells that no longer divide but accumulate in tissues, contributing to various age-related diseases and general decline in health. The discovery of ginketin, periplocin, and oleandrin as potent senolytics through AI analysis highlights the potential of machine learning in accelerating drug discovery processes. By analyzing the characteristics of thousands of chemicals and their effects on cells, AI can rapidly identify candidates that target specific cellular processes, offering new avenues for treatments aimed at extending health span and potentially lifespan. Understanding consciousness through fMRI. Functional magnetic resonance imaging, fMRI, is a non-invasive technology that measures brain activity by detecting changes in blood flow associated with neural activity. Researchers have utilized fMRI to gain insights into the neural mechanisms underlying consciousness, including how consciousness is maintained and what changes occur in the brain during disorders of consciousness, such as coma. By identifying specific brain circuitries and their alterations, this research opens up possibilities for understanding how consciousness emerges from brain activity, as well as for developing therapeutic interventions aimed at restoring consciousness in patients with severe brain injuries. Health risks of indoor gas stoves. Recent studies have raised concerns about the health risks associated with the use of gas stoves indoors, particularly the emission of benzene, a known carcinogen. Benzene levels measured in kitchens using gas stoves can exceed those found in environments contaminated with secondhand tobacco smoke, posing significant health risks to inhabitants. These findings highlight the importance of proper ventilation in kitchens and suggest that transitioning to alternative cooking methods such as electric or induction stoves could mitigate these health risks. It also calls for increased awareness and regulatory measures to protect indoor air quality and public health. Social isolation and loneliness impact on mortality. Research has established a link between social isolation, loneliness, and an increased risk of mortality. Social isolation refers to the objective lack of social contacts and interactions, while loneliness is the subjective feeling of being alone. Both conditions have been shown to have significant adverse effects on health, comparable to well-established risk factors such as smoking and obesity. The findings underscore the importance of social connections and interventions designed to reduce loneliness and social isolation as part of comprehensive public health strategies to improve overall well-being and longevity. Functional cryopreserved kidney transplant. The successful transplantation of a functional cryopreserved kidney using a novel nano-warming technique for vitrification marks a major advancement in organ preservation. This technique allows organs to be preserved for up to 100 days, significantly longer than current methods, by vitrifying or turning to glass. the organ at very low temperatures without the formation of damaging ice crystals. The nanowarming process then evenly warms the organ, restoring it to a functional state for transplantation. This breakthrough could dramatically increase the availability of organs for transplantation, reducing waiting times and potentially saving many lives. Projected increase in global diabetes prevalence. A concerning study projects that the global prevalence of diabetes is expected to more than double by 2050, affecting over 1.3 billion adults. This increase is attributed to aging populations, lifestyle changes, and rising obesity rates worldwide. No country is expected to see a decline in diabetes rates, highlighting the need for urgent action to address this growing public health crisis. Preventive measures, early detection, and effective management strategies are crucial to combat the rising tide of diabetes and mitigate its impact on individuals, healthcare systems, and economies around the globe. ESA's Euclid Space Telescope launch. The European Space Agency, ESA, embarked on a groundbreaking mission with the launch of the Euclid Space Telescope on 1 July. This ambitious project is designed to delve into the cosmic mysteries of dark energy and dark matter, which together account for most of the universe's content but remain elusive and poorly understood. Euclid's mission spans 6 years, during which it will survey billions of galaxies over a third of the sky. By analyzing the distribution, shapes, and redshifts, which indicate the distance and speed at which galaxies are moving away from us, of galaxies, Euclid aims to shed light on how the universe has expanded over billions of years and how its structures have evolved. This data will be pivotal in understanding the role of dark matter in galaxy formation and the influence of dark energy on the universe's expansion rate, offering new insights into fundamental physics.
DNA data storage with optogenetic circuits. Researchers have introduced a revolutionary technique for storing data in DNA by leveraging optogenetic circuits. This method does not require new DNA synthesis. Instead, it encodes data, such as images, by recording patterns of light exposure into the DNA of bacteria. Optogenetics combines optical, light-based, and genetic methods to control and monitor the activities of individual neurons in living tissue. By integrating these circuits into bacterial DNA, scientists have created a biological camera that captures and stores information in a biological medium. This approach represents a significant advancement in data storage technology, offering a compact, durable, and sustainable alternative to traditional electronic storage systems, with the potential for immense data density and longevity.
Discovery of interstellar material. Harvard astronomer Avi Loeb reported that the Galileo project might have identified material from outside our solar system, known as interstellar material. This discovery is significant because interstellar objects, such as dust, asteroids, or comets that originate from other star systems, can provide invaluable information about the chemical composition and physical processes of other parts of the galaxy. Analyzing these materials helps scientists understand the formation and evolution of planetary systems, including our own, and the potential for life elsewhere in the universe. It opens a new frontier in astronomy, where studying materials from beyond our solar system can offer clues to the broader cosmic context in which Earth resides. Synthetic minimal cells evolution experiment. In a landmark study, synthetic minimal cells, specifically JCVI Syn3B cells, with genomes reduced to 493 essential genes, demonstrated the ability to survive, mutate, and adapt. These cells represent the smallest genome of any free-living organism known. Despite a significant decrease in fitness compared to their predecessors, these minimal cells regained their vitality after approximately 2,000 generations under conditions of accelerated evolution. This experiment underscores the fundamental aspects of life and evolution, showing even with a drastically simplified genetic makeup, life finds pathways to adapt and thrive. It highlights the resilience and adaptability of living organisms and offers profound insights into minimal biological requirements for life. Methane release from Arctic glacial retreat. A recent study highlights a concerning environmental feedback loop where the retreat of Arctic glaciers, accelerated by global warming, could lead to significant releases of methane, a potent greenhouse gas. As glaciers melt, previously trapped methane in ice and permafrost is released into the atmosphere, contributing to further warming. This cycle poses a risk of exacerbating climate change effects, making Arctic emissions a critical area of study for understanding and mitigating global warming impacts. The study calls attention to the urgent need for comprehensive climate action to slow glacial retreat and prevent the release of vast methane reserves. Dynamic shell formation for fusion energy. Researchers have achieved a significant breakthrough in fusion energy technology by demonstrating dynamic shell formation for the first time. This process involves creating a stable, self-sustaining environment where nuclear fusion reactions can occur, akin to the conditions at the core of the Sun. Fusion energy promises a nearly limitless source of clean power by fusing light atomic nuclei, like hydrogen, to form heavier nuclei, releasing vast amounts of energy in the process. The experimental demonstration of dynamic shell formation marks a step towards making fusion energy a viable and scalable power source, potentially revolutionizing energy production with minimal environmental impact. Discovery of high-albedo exoplanet. Astronomers using the Cheops Space Telescope confirmed an ultra-hot Neptune-like exoplanet, LTT 9779b, with the highest albedo or reflectivity ever measured. The planet reflects 80% of the light from its star, surpassing even Venus due to the high metal content in its cloud composition. This discovery provides crucial insights into the atmospheric dynamics and cloud formation of exoplanets, particularly those in close orbits around their stars. Understanding the reflectivity and atmospheric composition of exoplanets like LTT 9779b aids in deciphering the myriad conditions that prevail on planets beyond our solar system, enriching our knowledge of planetary science and the potential for habitability in the universe. Dark star candidates and early universe insights. The James Webb Space Telescope, JWST, has identified potential dark star candidates, offering a glimpse into the universe's infancy, approximately 320 to 400 million years after the Big Bang. These dark stars are hypothesized to be early universe phenomena where dark matter annihilation might have provided the energy source for these stars, rather than nuclear fusion as in conventional stars. The observation of these candidates could revolutionize our understanding of dark matter's role in the structure and evolution of the universe. Investigating these dark stars provides a unique window into the conditions of the early universe, shedding light on the formation of the first stars and galaxies and the nature of dark matter. Warmest June on record. June 2023 was reported by Berkeley Earth as the warmest June since record-keeping began in 1850. Surpassing the previous record by 0.18 degrees C. This significant increase in global temperatures is a clear indication of the accelerating pace of climate change. The analysis suggests a high likelihood that 2023 could set a new record for annual global temperatures. This trend is alarming, as it underscores the tangible effects of global warming on our planet's climate system, affecting weather patterns, ecosystems, and biodiversity worldwide. The continuous rise in temperatures calls for urgent and comprehensive climate action to mitigate the impacts and address the root causes of climate change. Carbon taxation for luxury versus basic goods. A recent study proposes a more nuanced approach to carbon taxation, suggesting that taxes should differentiate between luxury and basic goods and services. This approach aims to make carbon taxation more equitable by imposing higher taxes on goods and services that are considered luxuries, thereby targeting emissions associated with higher consumption lifestyles without disproportionately affecting essential goods and services needed for everyday living. Such a strategy could encourage more sustainable consumption patterns among the wealthier segments of the population, while protecting lower-income individuals from the financial burden of carbon taxes. Implementing differentiated carbon taxation could enhance the social acceptance and fairness of climate policies, promoting a more sustainable and just transition towards a low-carbon economy. James Webb Space Telescope success. The James Webb Space Telescope, JWST, has marked its first year of operations with considerable success, heralding a new era in astronomical observation. The JWST, with its advanced infrared capabilities, allows astronomers to look further back in time and with greater detail than ever before. It has been instrumental in observing the early universe, studying the formation of stars and galaxies, and analyzing the atmospheres of exoplanets. The telescope's sophisticated instruments can capture light that has traveled across the cosmos for billions of years, providing insights into the universe's infancy and its subsequent evolution. The JWST's achievements underscore the potential for groundbreaking discoveries that could reshape our understanding of cosmic phenomena, the composition of celestial bodies, and the fundamental laws that govern the universe. Plastic and pesticide pollution studies. Global studies have highlighted the alarming prevalence of plastic pollution in lakes and reservoirs, and pesticide pollution in agricultural soils and rivers. These pollutants pose significant risks to ecosystems, water quality, and human health. Plastic pollution, including microplastics, affects aquatic life and enters the food chain, while pesticides can linger in the environment, contaminating soil and water, and harming both wildlife and humans. These studies emphasize the need for improved waste management, sustainable agricultural practices, and stricter regulations to mitigate the environmental impact of these pollutants and protect global biodiversity. Advances in gene therapy and longevity research. Recent advancements in gene therapy and longevity research offer promising prospects for reversing age-related decline and enhancing cognitive function. Studies have explored chemical alternatives to gene therapy using Yamanaka factors, which can revert adult cells to a more youthful state. Research involving the longevity factor A-klotho has shown potential for improving cognition in aged rhesus macaques. Additionally, experiments on heterochronic parabiosis in mice, where the circulatory systems of young and old mice are joined, have demonstrated enduring rejuvenation effects, even after separation. These findings pave the way for developing therapies that could extend health span, improve quality of life in aging populations, and unravel the biological mechanisms underlying aging. Discovery of naturally occurring graphene. For the first time, naturally occurring graphene has been reported in a gold mine in South Africa. Graphene, a single layer of carbon atoms arranged in a two-dimensional lattice, is renowned for its exceptional strength, electrical conductivity, and flexibility. The discovery of graphene in natural settings opens up new avenues for sourcing this material, potentially reducing the need for energy-intensive synthetic production methods. Natural graphene could revolutionize industries by providing a sustainable source of this versatile material for use in electronics, energy storage solutions, and composite materials, heralding new applications and innovations. Self-healing metals in vacuum. A groundbreaking discovery has shown that metals can self-heal fatigue cracks when placed in a vacuum. This phenomenon occurs as the absence of air in a vacuum environment allows metal atoms to move and fill in cracks without the interference of oxygen and other gases, effectively repairing the metal. This self-healing capability has profound implications for extending the lifespan and durability of metal structures and components used in aerospace, engineering, and other high-tech applications. By harnessing this property, it may be possible to develop metals and alloys that are more resilient to wear and tear, reducing maintenance needs and enhancing safety and reliability in critical infrastructure and technology. Air pollution's effect on insects. Recent research has illuminated the detrimental impact of air pollution on insects, specifically how particulate matter interferes with their ability to locate food and mates. Airborne pollutants, including fine particles emitted from vehicles and industrial processes, can obscure chemical signals or pheromones that insects rely on for survival and reproduction. This disruption could contribute significantly to the alarming global decline in insect populations observed in recent decades. Insects play essential roles in ecosystems as pollinators, decomposers, and as part of the food web. Thus, their decline poses a threat to biodiversity, agriculture, and overall ecosystem stability. Understanding the extent of air pollution's impact on insects is crucial for devising strategies to mitigate these effects and preserve vital ecological services. CRISPR and sustainable fiber production. The application of CRISPR gene editing technology to poplar trees represents a significant advancement in sustainable fiber production. By targeting and reducing the lignin content, the complex organic polymer that gives plants their rigidity, by up to 50%, scientists aim to streamline the process of converting wood into paper and other fiber products. Lignin removal is typically energy-intensive and requires harsh chemical treatments. But lowering lignin content genetically could make this process more efficient and environmentally friendly. This breakthrough not only showcases the potential of CRISPR for agricultural and industrial applications, but also opens the door to producing more sustainable materials, contributing to the reduction of the environmental footprint of paper production and other wood-based industries. ISRO's Chandrayaan-3 moon mission. The Indian Space Research Organization's ISRO Chandrayaan-3 mission marks a significant milestone in lunar exploration. Launched with the goal of achieving a soft landing on the moon's surface, ISRO aims to become the fourth space agency to accomplish this feat. The mission includes an orbiter, lander, and rover designed to study the lunar topography, mineral composition, and atmosphere, contributing valuable data to our understanding of the moon. Chandrayaan-3's success would not only underscore India's growing prowess in space technology and exploration, but also enhance global knowledge of the moon, potentially aiding future missions and the exploration of lunar resources. Breakthrough Listen's technique for alien signals. The Breakthrough Listen project has developed a novel technique to distinguish between potential extraterrestrial signals and Earth-based radio interference. This method relies on analyzing the unique effects that the interstellar medium has on radio waves. As signals travel through space, they pass through ionized plasma, which can alter their properties in distinguishable ways. By identifying these changes, scientists can better identify signals that truly originate from outer space, enhancing the search for extraterrestrial intelligence, SETI. This innovative approach could significantly improve our ability to detect and analyze communications from other civilizations, marking an exciting development in the ongoing quest to determine whether we are alone in the universe. Discovery of a two-faced star. Astronomers have discovered a unique two-faced white dwarf star, designated ZTF J2103349.8 Pol 3229 Rho 1.1, which presents an unprecedented composition with one side made of hydrogen and the other of helium. This discovery challenges existing theories of stellar evolution and composition, as stars typically have a more uniform distribution of elements. The peculiar nature of this white dwarf, located about 1,000 light-years away, could provide new insights into the processes that occur in stars' end-of-life stages and contribute to our understanding of stellar remnants. Investigating how this star acquired its unusual characteristics could reveal new aspects of astrophysics and the life cycle of stars. Study on bullshit jobs. A study investigating the concept of bullshit jobs has provided evidence that a significant number of workers perceive their jobs as making no meaningful contribution to society. This term, popularized by anthropologist David Graeber, refers to positions that even those who hold them view as unnecessary. The findings highlight a critical aspect of contemporary work culture, where the perceived value and impact of one's job on society play crucial roles in job satisfaction and mental well-being. Understanding the prevalence and effects of such perceptions is vital for addressing issues of employee engagement, productivity, and the broader implications for economic and social systems. This research invites reflection on the nature of work, the value of different occupations, and how societies can better align jobs with meaningful contributions to the common good. Global warming, ocean and July temperature records. In August 2023, global warming's impact was starkly illustrated when the world's oceans hit a record-high temperature of 20.96 degrees Celsius, surpassing the previous high set in 2016. Concurrently, July was officially the hottest month on record for globally averaged surface air temperatures, marking a significant deviation from historical climate patterns. These records are critical because they reflect the ongoing trend of global warming, driven by increased greenhouse gas emissions. Warmer oceans can lead to more extreme weather events, such as hurricanes and heat waves, and impact marine ecosystems by causing coral bleaching and altering fish populations. The record-breaking temperatures serve as a clarion call for urgent action to mitigate climate change and adapt to its effects. Theoretical limits on advanced civilizations on low-oxygen planets. Astrobiologists have posited that planets with low oxygen levels may be unsuitable for developing advanced civilizations due to the necessity of fire for technological progression. Fire, essential for metalworking, cooking, and energy production in early human history, requires an atmosphere with an oxygen partial pressure above 18% for open-air combustion. This theory suggests that the atmospheric composition of exoplanets, a key factor in the search for extraterrestrial life, could significantly influence the potential for the emergence of complex life forms and technological societies, emphasizing the role of oxygen in the development of civilizations. Unusually large gas giant, around a small star. The discovery of TOI 4860b, an unusually large gas giant orbiting the small star TOI 4860, challenges existing models of planetary formation. This system, featuring the lowest mass star known to host such a high-mass planet, suggests that planetary formation processes can result in a wider variety of star-planet mass relationships than previously understood. Traditional theories have implied that small stars typically host smaller, rocky planets, but this finding indicates that even low-mass stars can have significant gas giants, opening new avenues for research into how planets form and evolve across different types of stellar systems. Discovery of an ancient human hominin in China. Researchers in China have uncovered evidence of an ancient human hominin species that may have lived around 300,000 years ago. This discovery adds a new chapter to the human evolutionary story, highlighting the complexity and diversity of hominin species that existed on Earth. The finding provides insights into the migration, adaptation, and interaction of early human ancestors, contributing to our understanding of human ancestry and the evolutionary processes that shape the development of Homo sapiens. Dogsim, the first known fox-dog hybrid. Dogsim represents the first documented hybrid between a fox and a domesticated dog, discovered in the wild in Brazil in 2021. This rare interspecies hybridization offers unique insights into genetic exchange and adaptability among canids. The existence of Dogsim challenges our understanding of reproductive barriers between different species and provides an opportunity to study the genetic and ecological implications of such hybrids in the wild, shedding light on the complexities of natural hybridization and its impact on biodiversity and evolution. Walking more than 3,167 steps reduces mortality risk. A global study involving 226,000 participants found that walking more than 3,167 steps daily significantly reduces the risk of premature death from any cause, challenging the widely cited recommendation of 10,000+ steps a day. This research suggests that even moderate levels of daily physical activity can have substantial health benefits, emphasizing the importance of incorporating walking into daily routines to improve public health outcomes. The findings advocate for more accessible activity targets, encouraging individuals to engage in regular exercise for better health and longevity. Most precise measurement of the muon's magnetic moment. Scientists at Fermilab have achieved the most precise measurement yet of the magnetic moment of the muon, revealing that these subatomic particles wobble faster than predictions made by the standard model of particle physics. This discrepancy hints at new physics beyond the standard model, possibly indicating the existence of a fifth fundamental force. The muon's behavior challenges our current understanding of the universe's fundamental forces and particles, opening the door to groundbreaking discoveries that could transform the field of particle physics. Discovery of Earth's heaviest ever animal. The whale Parusetus colossus from the Eocene epoch has been identified as potentially the heaviest animal to have ever existed on Earth, with estimates ranging from 85 to 340 tons. This discovery redefines our understanding of the size range of ancient marine mammals, offering new perspectives on the evolutionary history of whales. Studying Parusetus colossus provides valuable insights into the ecological dynamics of ancient oceans and the evolutionary adaptations that enabled such immense creatures to thrive, contributing to our broader knowledge of life on Earth and its history. Rise in photosynthesis, rate slowing. Recent studies have observed a significant slowdown in the global increase of photosynthesis rates, a change attributed primarily to the atmosphere becoming drier over the 21st century. Photosynthesis, the process by which plants convert sunlight, water, and CO2 into oxygen and glucose, has been accelerating due to higher CO2 levels, acting as a natural mitigator against climate change by absorbing more CO2. However, drier atmospheric conditions limit this effect, potentially altering carbon cycle dynamics and affecting global food security and climate models. This finding underscores the complex interplay between plant life and climate change, indicating that rising CO2 levels cannot indefinitely enhance plant growth without sufficient water. DNA methylation profiles across mammalian species. A groundbreaking effort by a global consortium has led to the compilation of DNA methylation profiles across 348 mammalian species. DNA methylation, a key epigenetic mechanism, involves the addition of a methyl group to DNA, influencing gene expression without changing the DNA sequence. This vast dataset provides insights into aging processes, showcases the diversity of epigenetic regulation among mammals, and enhances the development of epigenetic clocks. These clocks can accurately estimate the biological age of tissues and predict the risk of age-related diseases, offering profound implications for understanding aging, improving human health, and extending longevity. Comet Nishimura discovery.
Comet Nishimura, C 2023 P1 Nishimura, discovered by amateur astronomer Hideo Nishimura, is a long-period comet that captured the attention of both the scientific community and skywatchers. Long-period comets are icy bodies originating from the distant Oort cloud, making their way into the inner solar system, possibly for the first time in thousands or millions of years. The visibility of Comet Nishimura provided a unique opportunity for observation and study, contributing to our understanding of the solar system's formation and the nature of cometary materials.
First image of quantum entanglement. The first-ever image of quantum entanglement represents a significant achievement in visualizing a foundational concept in quantum physics. Entanglement is a phenomenon where particles become interconnected in such a way that the state of one particle instantaneously influences the state of another, regardless of the distance separating them. Capturing this phenomenon in an image not only provides direct visual evidence of entanglement, but also enhances our understanding of quantum mechanics and its potential applications in quantum computing and secure communications. India's Chandrayaan-3 moon landing. India's Chandrayaan-3 mission achieved a historic milestone by landing near the south pole of the moon, a region believed to contain frozen water. This success places India among the few nations that have managed a soft landing on the lunar surface. The mission aims to study the moon's topography, mineral composition, and potential water ice deposits, contributing valuable data to global lunar research efforts. Chandrayaan-3's accomplishments underscore India's growing capabilities in space exploration and the importance of international contributions to advancing lunar science. Complete sequencing of the human Y chromosome. Scientists have achieved the complete sequencing of the human Y chromosome, discovering 41 additional genes not previously identified. This comprehensive sequencing effort also revealed significant variability in the Y chromosome among individuals, with sizes ranging dramatically. The Y chromosome plays a crucial role in male development and reproduction, and this detailed sequencing provides new insights into human genetic diversity, male-specific diseases, and evolutionary biology, opening new avenues for research into human health and history. Longevity factors transferable between species. Research has indicated that longevity factors, particularly those identified in long-living species like naked mole rats, can be transferred to other species, such as mice, potentially extending lifespan and improving health. These findings suggest that mechanisms underlying longevity and resistance to age-related diseases may be conserved across species, offering exciting possibilities for developing anti-aging therapies that could one day be applied to humans, aiming to enhance a health span and quality of life. Global warming and potential mass deaths. A study has projected that global warming of 2 degrees by 2100 could lead to mass deaths of 1 billion people due to extreme heat, highlighting the severe human health implications of climate change. This stark projection emphasizes the urgency of mitigating global warming to prevent catastrophic impacts on human populations, particularly in regions most vulnerable to heat-related mortality. The study calls for immediate and significant action to reduce greenhouse gas emissions and adapt to changing climate conditions. Jupiter Impact Event filmed. Astronomers captured an impact event on Jupiter, likely caused by an asteroid, providing a rare opportunity to observe and study such celestial collisions. These events are crucial for understanding the dynamics of our solar system and the potential threats posed by space objects. Filming the impact on Jupiter not only offers insights into the composition and behavior of impacting bodies, but also helps refine models of planetary defense mechanisms and the role of giant planets in shielding the inner solar system from frequent collisions. Standard model of cosmology questioned. Recent studies using data from the James Webb Space Telescope have prompted astrophysicists to question the standard model of cosmology, which is the prevailing theoretical framework describing the universe's composition, structure, and evolution. This model, which includes concepts like dark matter and dark energy, has been foundational in understanding the universe's expansion and the distribution of galaxies. However, the new observations suggest there may be discrepancies in our understanding, potentially pointing to unknown aspects of the universe that aren't accounted for in the current model. Such questioning could lead to significant shifts in cosmological theories, offering deeper insights into the fundamental nature of the cosmos. Warmest September on record. September 2023 was recorded as the warmest September globally, with an average surface air temperature 0.5 degrees C above the previous record set in 2020. This record is a stark indicator of the ongoing global warming trend, driven by human-induced climate change. The rising temperatures have profound implications for weather patterns, ecosystems, and sea levels worldwide. This milestone underscores the critical need for comprehensive climate action to mitigate further temperature increases and adapt to their impacts. Discovery of Ho'olelana galactic structure. Astronomers have identified a vast, bubble-like structure in the universe, known as Ho'olelana, measuring approximately 1 billion light-years across. This structure represents the first observation of an individual baryon acoustic oscillation, a phenomenon originating from the early universe that influenced its large-scale structure. Baryon acoustic oscillations are essentially sound waves propagated through the dense plasma of the early universe, leaving imprints that helped shape the distribution of galaxies. Understanding structures like Ho'olelana provides invaluable insights into the universe's formation and evolution. Specialized astrocytes in the central nervous system. Researchers have discovered specialized astrocytes involved in glutamatergic gliotransmission within the central nervous system. Astrocytes, a type of glial cell, play critical roles in supporting and modulating neuronal activity. This particular discovery highlights astrocytes' involvement in neurotransmission, specifically in the glutamatergic system, which is essential for cognitive functions such as learning and memory. Understanding these cells' specific roles could pave the way for novel treatments for neurological disorders. Largest known lithium deposit. Geologists have discovered potentially the largest known lithium deposit within the crater of a dormant volcano along the Nevada-Oregon border, estimated to contain 20 to 40 million tons of lithium. This metal is crucial for battery production, especially for electric vehicles and renewable energy storage systems. The discovery could significantly impact the global supply of lithium, addressing the growing demand for sustainable energy solutions and reducing reliance on fossil fuels. Evolutionary link to reduction in prey size. A study proposes a theory linking a reduction in prey size during the Paleolithic era to significant advancements in human technologies and cognitive abilities. As early humans adapted their hunting strategies to target smaller prey, this necessitated the development of more sophisticated tools, weapons, and collaborative hunting strategies, driving cognitive and technological evolution. This link between environmental challenges and human development underscores the adaptability and ingenuity of early humans. Sleep timing regularity's importance. The National Sleep Foundation provided the first consensus statement on the importance of sleep timing regularity for health and performance. Consistent sleep patterns are now recognized as critical for maintaining physical health, mental well-being, and optimal performance in daily activities. Irregular sleep schedules can disrupt the body's internal clock, leading to various health issues. This consensus emphasizes the need for regular sleep routines to support overall health. Carbon dioxide and methane on potentially habitable exoplanet. The James Webb Space Telescope detected carbon dioxide and methane in the atmosphere of K2-18b, suggesting it might be a Hycean planet covered in oceans of water with a hydrogen-rich atmosphere. This discovery of a potentially habitable exoplanet about 8.6 times the mass of Earth opens up exciting possibilities for the study of extraterrestrial life and the conditions that support habitability in the universe. LCLS-2, world's most powerful X-ray laser. The upgrade of the Linux coherent light source to LCLS-2 at the SLAC National Accelerator Laboratory resulted in the world's most powerful X-ray laser. This laser can produce X-rays that are 8,000 times faster and 10,000 times brighter than its predecessor, enabling unprecedented studies of atomic and molecular structures. The LCLS-2 will significantly advance research in materials science, chemistry, biology, and physics. Sixth mass extinction event acceleration. Scientists have calculated that animal genera are going extinct at a rate 35 times faster than the expected background rates over the past million years, indicating a human-driven sixth mass extinction event that is accelerating. This rapid loss of biodiversity is primarily due to human activities, such as habitat destruction, pollution, and climate change. The acceleration of this extinction event highlights the urgent need for conservation efforts to preserve the planet's remaining biodiversity. New view of the cosmos and instantons. Astrophysicists, utilizing the latest observations from the James Webb Space Telescope, propose a revolutionary view of the universe, suggesting it may have originated from instantons and could essentially be a black hole. Instantons are theoretical mathematical constructs representing tunneling events in quantum field theory, which could potentially explain the universe's initial conditions. This new perspective challenges the traditional Big Bang model, offering a more complex scenario where the universe's birth and structure are tied to phenomena akin to black holes, where space and time are intensely curved. This theory could significantly alter our understanding of cosmic origins, potentially unifying various aspects of physics under a new cosmological paradigm. Nobel Prize for mRNA vaccines. Katalin Karikó and Drew Weissman were awarded the Nobel Prize in Physiology or Medicine for their foundational work in the development of mRNA vaccine technology. This groundbreaking research was crucial in the rapid creation of effective vaccines against COVID-19. mRNA vaccines work by using messenger RNA to instruct cells to produce a protein that is part of the virus, triggering an immune response without using live virus particles. This method represents a significant advancement in vaccine technology, offering faster development times and adaptable platforms for various diseases, showcasing a monumental shift in medical science. Discovery of Jupiter-sized rogue planets. The James Webb Space Telescope has identified pairs of Jupiter-sized rogue planets, dubbed Jupiter Mass Binary Objects, JUMBIOs, within the Orion Nebula. Unlike conventional planets that orbit stars, these rogue planets drift freely through space. The discovery of such massive planets in binary pairs without a stellar anchor challenges existing models of planetary formation and suggests a broader diversity of celestial phenomena than previously understood. This finding expands our knowledge of the universe's complexity, revealing that massive planets can form and exist even in the absence of a central star. Nobel Prize in Physics for Electron Movement. The Nobel Prize in Physics was awarded to Pierre Agostini, Ferenc Krauss, and Anne Le Huillier for their pioneering work in understanding electron dynamics. Their research has illuminated the incredibly fast movements of electrons within atoms, employing techniques that allow scientists to observe these subatomic particles in action. This achievement opens new avenues in physics, enabling precise studies of atomic and molecular processes that occur on timescales of attoseconds, billionths of a billionth of a second, crucial for advancements in quantum mechanics, photonics, and potentially in developing new materials and technologies. Same-sex behavior in animals. Biological studies across over 1,500 different animal species have observed that same-sex behavior, distinct from human sexual orientation, may play a significant role in promoting social stability within groups. Such behaviors can reduce conflict and competition, fostering cooperative dynamics that benefit group living. This research underscores the natural diversity of sexual behaviors in the animal kingdom and suggests that these behaviors can have adaptive value, contributing to the understanding of social and evolutionary biology. Nobel Prize in Chemistry for Quantum Dots. The Nobel Prize in Chemistry was awarded to Maungi G. Bawendi, Louis E. Bruce, and Alexei Ekimov for their work in discovering and developing quantum dots. Quantum dots are nanoscale semiconductor particles that possess unique optical and electronic properties due to quantum mechanics. When illuminated, they can emit light at various wavelengths controlled by their size. This technology has profound implications for electronics, photonics, and biomedical imaging, offering brighter displays, improved solar cells, and targeted drug delivery systems. Light, circadian clocks, and health. A comprehensive review involving 248 scientists highlights the critical relationship between light exposure, circadian rhythms, and health. Despite the known health impacts of light, especially its ability to disrupt circadian rhythms and affect sleep patterns, modern lighting solutions rarely adjust for spectral content and intensity variations between day and night. This oversight underscores a gap in applying our understanding of circadian health to practical technologies, pointing to a need for lighting that supports natural biological rhythms. Gene-edited chickens resistant to bird flu. Researchers at the University of Edinburgh's Roslin Institute have developed gene-edited chickens that exhibit partial resistance to avian influenza, bird flu. By altering specific genes, these chickens are less likely to fall ill and spread the virus, representing a significant step towards mitigating the impact of bird flu outbreaks in poultry. This advance not only has the potential to improve animal welfare and reduce economic losses, but also lowers the risk of zoonotic transmission to humans. Afterglow of exoplanet collision. Astronomers observed the first known afterglow of a collision between two exoplanets around a sun-like star located 1/800 light-years away. This rare glimpse into the violent interactions that can occur in planetary systems provides valuable insights into the dynamics of planet formation and evolution. Studying the aftermath of such collisions helps scientists understand the processes that lead to the diverse array of planetary systems observed throughout the galaxy. Psyche mission launch. NASA's Psyche mission was launched to explore the asteroid 16 Psyche, a large metallic body in the asteroid belt that is believed to be the exposed core of an early planetesimal. This mission aims to study its composition, providing insights into the building blocks of planet formation and the processes that form terrestrial planets' cores. The Psyche asteroid offers a unique laboratory for examining the metallic interior of planets, a component typically hidden beneath rocky mantles and crusts, potentially revealing more about the solar system's formation and the differentiation of its planets. World's first AI Summit. In November 2023, the UK hosted the world's first international summit dedicated to safely managing artificial intelligence, AI. This landmark event brought together global leaders, researchers, and policymakers to discuss and develop strategies for the ethical development, deployment, and governance of AI technologies. Amidst rapid advancements in AI, concerns about privacy, security, fairness, and the impact on employment have grown. The summit aimed to address these challenges by fostering international collaboration and setting guidelines to ensure AI benefits society without compromising human rights or safety. Thea's remnants inside Earth. Thea, a protoplanet involved in a giant collision with the early Earth, is theorized to have left remnants inside our planet, based on computer simulations. This collision, occurring over 4.5 billion years ago, is also credited with forming the Moon. The simulations suggest that instead of completely merging or being obliterated, parts of Thea might have sunk into Earth's mantle, potentially affecting its composition and dynamics. This theory offers a deeper understanding of Earth's geological history and its formation, highlighting the complex outcomes of planetary collisions in the solar system. Dinkinesh, a binary asteroid system. NASA's Lucy probe discovered that Dinkinesh, initially thought to be a single asteroid, is actually a binary system comprising two gravitationally bound celestial bodies. This revelation adds to our understanding of the diversity and complexity of asteroid systems. Studying binary asteroids like Dinkinesh helps scientists learn more about asteroid formation and evolution, providing insights into the early solar system's dynamics. Breakthrough in solar cell efficiency. A significant breakthrough was achieved in solar cell technology, with the development of a silicon perovskite tandem solar cell boasting a record efficiency of 33.9%. This efficiency surpasses the Shockley-Queisser limit for single-junction solar cells, traditionally capped at 33.7%. Tandem solar cells leverage two different light-absorbing layers to capture a broader spectrum of sunlight, converting more of it into electricity. This advancement represents a major step forward in photovoltaic technology, promising more efficient renewable energy sources to combat climate change. UK forests' ecosystem collapse. A University of Cambridge study warns of a catastrophic ecosystem collapse in UK forests within the next 50 years, attributing the potential collapse to a range of factors, including climate change, disease, and human activity. This prediction emphasizes the urgent need for comprehensive strategies to protect and preserve forest ecosystems, which play critical roles in biodiversity, carbon sequestration, and human well-being. First human eye transplant. Surgeons reported the first human eye transplant attempt. However, the patient did not regain sight in the transplanted eye. This pioneering procedure represents a groundbreaking moment in medical science, offering potential pathways for future research into restoring vision. Although this initial attempt did not result in sight recovery, it lays the foundation for understanding the complexities and possibilities of eye transplantation. Scalable carbon nanotube MOSFETs. Researchers at the University of California, San Diego, and the Taiwan Semiconductor Manufacturing Company demonstrated a scalable technique for creating carbon nanotube-based metal oxide semiconductor field effect transistors, MOSFETs. Carbon nanotubes offer superior electrical properties compared to silicon, including better conductivity and the potential for smaller, faster, and more energy-efficient electronic devices. This advancement could revolutionize semiconductor technology, paving the way for the next generation of electronics. AI-generated white faces, perceived as more real. A study conducted by the Australian National University found that white faces generated by AI are often perceived as more real than actual human faces, a bias not observed with faces of people of color. This research underscores the inherent biases in AI algorithms and the importance of developing AI systems that are diverse and unbiased, reflecting the real world's complexity and diversity. Iceland's volcanic instability. Following a series of recent eruptions on the Reykjanes Peninsula, geologists report that Iceland may face decades of volcanic instability, ending an 800-year period of quiescence. This forecast highlights the need for continuous monitoring and preparedness to mitigate the impacts of volcanic activity on Iceland's population and global aviation. 3D printing of hair follicles. Scientists at the Rensselaer Polytechnic Institute in New York achieved the 3D printing of hair follicles on lab-grown skin. This technological breakthrough in tissue engineering could lead to new treatments for hair loss and advances in skin graft techniques. By creating functional hair follicles, this research moves closer to replicating complex biological structures, opening new avenues in regenerative medicine and cosmetic surgery. Ancient Earth-like area in Puna de Atacama. In the Puna de Atacama territory of South America, scientists have identified a region that closely resembles the environmental conditions of ancient Earth, offering a window into the planet's early life-supporting environment. This area's unique conditions also parallel what scientists believe could have existed on Mars during its more hospitable past. Studying such regions on Earth provides invaluable insights into the origins of life and the potential for life on other planets, highlighting the importance of preserving and studying these natural laboratories to understand life's universal conditions. Google DeepMind's Gemini multimodal language model. Google DeepMind announced Gemini, a cutting-edge multimodal language model, claiming superior reasoning capabilities and the ability to outperform GPT-4 in various tasks. Unlike traditional models that process text alone, Gemini's multimodal capabilities mean it can understand and generate information across different formats, such as text, images, and possibly sounds, enhancing AI's ability to interpret complex data. This advancement opens new possibilities for AI applications in areas like automated reasoning, content creation, and complex problem-solving. Gene therapy for vision recovery in glaucoma. Researchers have developed a gene therapy using 3 transcription factors, OKIT4, SOX2, and KLF4, OSK, to restore vision in mice with glaucoma. This therapy works by reprogramming cells to a more youthful state, potentially reversing damage caused by the disease. If successful in humans, this approach could revolutionize the treatment of glaucoma and other degenerative eye conditions, offering hope for millions affected by vision loss, highlighting the potential of gene therapy in regenerative medicine. Future plans in particle physics. Physicists have laid out a roadmap for the next decade, aiming to tackle some of the most pressing questions in particle physics. These include exploring the mysteries of gravity, black holes, dark matter, dark energy, the Higgs boson, muons, and neutrinos. By focusing on these areas, scientists hope to address challenges to the standard model of particle physics and deepen our understanding of the universe's fundamental components and forces, potentially leading to new discoveries and technologies. Quantum entanglement of molecules. For the first time, researchers at Princeton University achieved quantum entanglement with molecules, a significant milestone in quantum physics. Quantum entanglement is a phenomenon where particles become interconnected, such that the state of one instantly influences the state of another, regardless of distance. This achievement opens up new possibilities for quantum computing and secure communications, leveraging the entanglement of larger, more complex units than previously possible. Ancient carbon dioxide levels study. A comprehensive study by over 80 researchers from 16 nations has found that current atmospheric carbon dioxide levels are the highest in at least 14 million years. This research provides a long-term perspective on Earth's climate, indicating that human activities have driven CO2 concentrations to unprecedented levels, significantly impacting global warming and climate change. The study underscores the urgency of addressing carbon emissions to mitigate future climate risks. Organic molecules in asteroid Bennu samples. The sample return mission from asteroid Bennu, conducted by the OSIRIS-REx spacecraft, revealed the presence of organic molecules alongside unknown materials. These findings are crucial for understanding the building blocks of life in the universe, and could shed light on the chemical processes that led to the emergence of life on Earth, as well as inform the search for life on other celestial bodies. Discovery of the smallest known brown dwarf. Using the James Webb Space Telescope, astronomers discovered the smallest known brown dwarf, with a mass only 3 to 4 times that of Jupiter, in the star cluster IC 348. This discovery challenges our understanding of the formation of stars and planets, suggesting that the line between the smallest stars and the largest planets is even blurrier than previously thought, and highlighting the diversity of objects in the universe. Highest global average surface temperature. The year 2023 was recorded as having the highest global average surface temperature in history. This alarming milestone underscores the accelerating pace of global warming, driven by human-induced climate change. The rising temperatures pose significant challenges to ecosystems, weather patterns, and human societies, emphasizing the need for urgent action to reduce greenhouse gas emissions and mitigate climate impacts. AI's first scientific discovery. Google DeepMind claims to have made the first-ever scientific discovery using an AI chatbot. By developing a fact-checker to sift through and eliminate unreliable outputs, the AI was able to present only credible solutions to complex mathematical and computing problems. This achievement demonstrates AI's potential to contribute to scientific research, offering a new tool for discoveries and innovations across various disciplines. Machine intelligence replication. Researchers in the United States reported that machine intelligence has, for the first time, shown the capability of replicating without human intervention. This development implies that larger AI models such as ChatGPT can autonomously create smaller, specialized AI applications. While this represents a significant advancement in AI development, it also raises important ethical and practical questions about AI autonomy and the future of human-AI interaction. Wow, what a journey through the unknown we've just taken together. If you found these scientific breakthroughs as mind-blowing as we did, hit that like button to let us know. Dive into the comments below and share which discovery amazed you the most, or if there's something incredible we missed. Don't forget to subscribe for more awe-inspiring content and explore our channel for even more wonders waiting to be uncovered. Thanks for watching, and until next time, keep questioning, keep discovering, and stay curious.